Let us study today universal gravitation. Here it is the study material which I have developed in fact by myself. It contains gravitational force, gravitational field, gravitational intensity, gravitational potential, all these things. Universal gravitation. Okay. Now, gravitational phenomena has explained by the following scientists: Newton's Newton's law of gravitation, Albert Einstein, general theory of relativity. They are two different scientists. They have developed in gravitation by their own way. But we will confine our study here on Newton's law of gravitation, which is limiting case. In fact, it is limiting case of the Albert Einstein theory of relativity. Now, first, let us know the Kepler's law of motion. What it is? Kepler states that every planet around the sun, revolve around the sun in an elliptical orbit while sun is situated on of its focus. Okay. Second is planet revolving round the sun generate equal vectorial area in equal time interval. Third, the square of the time period is proportional to the cube of the radius vector of the path. T square proportional to Newton's laws of gravitation. Here it is. Newton's laws of gravitation. So I tell you, uh, okay, all right. Uh, what is said? Every mass particle apply a force of attraction on another mass particle, and the force is known as gravitational force. Here I have taken m1, one mass, m1, m2, and distance between them is r. All right. It is further explained as if two point masses say m1 and m2 are placed placed at a distance r, then the gravitational force applied by m1 and m2 is same as the gravitational force applied by m2 on m1. In fact, force is same means magnitude of the force is same. If the magnitude of force is taken to be F, then according to the Newton's law of gravitation, force F is proportional to the product of masses, and force F is inversely proportional to the square of the distance. Alright. So F proportional to m1 and into m2, m proportional to 1 upon r square. So finally it gives you F is equal to capital G into m1 into m2 upon r square. One thing, okay, F is equal to G into m1 into m2 upon r square, where G is a constant known as universal gravitational constant. F is equal to into m1 into m2 upon r square. Definition: universal gravitational constant G is defined as the universal gravitational force acting between two unit masses placed at a distance placed at a distance 1. I mean, say m1 is 1, m2 is 1, r is 1, then F is equal to G. Unit distance placed at unit distance. So this is I have written unit distance. Okay. Now definition 2. Universal gravitational constant G is defined as the gravitational force in Newton acting between two 1 kg 1 kg point masses placed at a distance of 1 meter. we have to study in detail the following topics. What are gravitational field, gravitational intensity, gravitational potential? Okay, so gravitational field. What is gravitational field? Gravitational field due to a mass is the region around the mass in which unit test mass experiences gravitational pull due to the given mass. But mathematically, we cannot have any mathematical boundary line of the field. It is the order of the force which decide mathematical boundary line. Now, intensity of gravitational field. What it is? For that, we define it as intensity of gravitational field at a point inside the field is the gravitational pull experienced by unit mass placed at the point. It is a vector quantity, mind it. Intensity of a gravitational field due to a mass m at a distance r is given by mathematically given by F is equal to g into m upon r square. Now, intensity due to Earth's gravitational field. Intensity of gravitational field. Intensity of gravitational field above the Earth's surface. In let there be a point P on of a height P at a height let's say above the Earth's surface where unit mass is placed to get the intensity due to Earth gravitational field. According to definition of intensity, will the gravitational pull experienced by the unit mass, which will be given as intensity E is equal to G into ME mass of Earth applied by the force mass, RE into H by whole square. Generally, it is represented by G dash. Here it is. Uh, if you want to little bit more, I can show you something extra also. Let us try that. What I do now, one thing I will show you. Okay, open orbital operation G with. Okay, all right. Here, hmm. Intensity of gravitational field at Earth's surface. Let there be a point P on the Earth's surface where point mass where unit mass is placed. I will show it here also. Here is the object. Here is the Earth. Okay, I mean this is the Earth. Here is the unit mass placed, and radius of Earth is 6500 kilometer. Object height is 6.9 times of the Earth radius. So what I have calculated it here, I show you that here it is. Here G is, as you know, Earth surface. G is equal to G into ME upon RE square. G dash GME upon RE plus H whole square. Why RE plus whole square? Because R is the Earth radius, H is the height. So what I have taken RE plus H whole square, G dash upon G is this much. This way I wanted to tell you about uh, this. All right. Now let us proceed on. So this is why I have used. This is the formula. Intensity there according to definition GME upon R square this much. This is the formula in Gn Earth radius and Earth density form. G is equal to. But basically you can write G is equal to GME upon R square. but it is the formula. G is this much. Now at a high touch, what it will be? So what I have shown you, the same thing is it here. This is the formula. G dash GME upon RE plus H whole square G is equal to, and divide this to, will get the relation between G dash and G. Alright. So if you do numerical, you can contact me and get the things as well. Alright. लगता है लोग आ गए.